1.4 Section Exercises. A. Verbal. 1. How does one find the domain of the quotient of two functions, f over g? 2. What is the composition of two functions, f, composed with g? 3. If the order is reversed when composing two functions, can the result ever be the same as the answer in the original order of the composition? If yes, give an example. If no, explain why not. 4. How do you find the domain for the composition of two functions, f, composed with g? B. Algebraic. 5. Given f of x equals x squared plus 2x and g of x equals 6 minus x squared. Find f plus g, f minus g, f, g, and f over g. Determine the domain for each function in interval notation. 6. Given f of x equals negative 3x squared plus x and g of x equals 5. Find f plus g, f minus g, f, g, and f over g. Determine the domain for each function in interval notation. 7. Given f of x equals 2x squared plus 4x and g of x equals 1 over 2x. Find f plus g, f minus g, f, g, and f over g. Determine the domain for each function in interval notation. 8. Given f of x equals 1 over x minus 4 and g of x equals 1 over 6 minus x. Find f plus g, f minus g, f, g, and f over g. Determine the domain for each function in interval notation. 9. Given f of x equals 3x squared and g of x equals square root of x minus 5. Find f plus g, f minus g, fg, and f over g. Determine the domain for each function in interval notation. 10. Given f of x equals square root of x and g of x equals the absolute value of x minus 3. Find g over f. Determine the domain for each function in interval notation. 11. Given f of x equals 2x squared plus 1 and g of x equals 3x minus 5. Find the following. A. F of g of 2. B. F of g of x. C. G of f of x. D. G, composed with g at x. E. F, composed with f at negative 2. For the following exercises, use each pair of functions to find f of g of x and g of f of x. Simplify your answers. 12. F of x equals x squared plus 1. G of x equals square root of x plus 2. 13. F of x equals square root of x plus 2. G of x equals x squared plus 3. 14. F of x equals the absolute value of x. G of x equals 5x plus 1. 15. F of x equals cube root of x. G of x equals x plus 1 over x cubed. 16. F of x equals 1 over x minus 6. G of x equals 7 over x plus 6. 17. F of x equals 1 over x minus 4. G of x equals 2 over x plus 4. For the following exercises, use each set of functions to find f of g of h of x. Simplify your answers. 18. F of x equals x to the fourth power plus 6. G of x equals x minus 6 and h of x equals square root of x. 19. F of x equals x squared plus 1. G of x equals 1 over x and h of x equals x plus 3. 20. Given f of x equals 1 over x and g of x equals x minus 3. Find the following. A. F composed with g at x. B. The domain of f composed with g at x in interval notation. C. G composed with f at x. D. The domain of g composed with f at x. E. Open parenthesis f over g closed parenthesis x. 21. Given f of x equals square root of 2 minus 4x and g of x equals negative 3 over x. Find the following. A. G composed with f at x. B. The domain of g composed with f at x in interval notation. 22. Given the functions f of x equals 1 minus x over x and g of x equals 1 over 1 plus x squared. Find the following. A. G composed with f at x. B. G composed with f at 2. 23. Given functions p of x equals 1 over square root of x and m of x equals x squared minus 4. State the domain of each of the following functions using interval notation. A. P of x over m of x. B. P of m of x. C. M of p of x. 24. Given functions q of x equals 1 over square root of x and h of x equals x squared minus 9. State the domain of each of the following functions using interval notation. A. Q of x over h of x. B. Q of h of x. C. H of q of x. 25. For f of x equals 1 over x and g of x equals square root of x minus 1. Write the domain of f composed with g at x in interval notation. For the following exercises, find functions f of x and g of x so the given function can be expressed as h of x equals f of g of x. 26. H of x equals open parenthesis x plus 2 closed parenthesis all squared. 27. H of x equals open parenthesis x minus 5 closed parenthesis all cubed. 28. H of x equals 3 over x minus 5. 29. H of x equals 4 over open parenthesis x plus 2 closed parenthesis all squared. 30. H of x equals 4 plus cube root of x. 31. H of x equals cube root of 1 over 2x minus 3. 32. H of x equals 1 over open parenthesis 3x squared minus 4 closed parenthesis to the power of negative 3. 33. H of x equals fourth root of 3x minus 2 divided by x plus 5. 34. H of x equals open parenthesis 8 plus x cubed divided by 8 minus x cubed closed parenthesis to the fourth power. 35. H of x equals square root of 2x plus 6. 36. H of x equals open parenthesis 5x minus 1 closed parenthesis all cubed. 37. H of x equals cube root of x minus 1. 38. h of x equals the absolute value of x squared plus 7. 39. h of x equals 1 over, open parenthesis, x, minus 2, closed parenthesis, all cubed. 40. h of x equals, open parenthesis, 1 over, 2x, minus 3, closed parenthesis, all squared. 41. h of x equals, square root of 2x, minus 1, divided by 3x, plus 4. C. Graphical. For the following exercises, use the graphs of f, shown in Figure 4, and g, shown in Figure 5, to evaluate the expressions. Figure 4. X. f of x, f. Figure 5. X. g of x, g. 42. f of g of 3. 43. f of g of 1. 44. g of f of 1. 45. g of f of 0. 46. f of f of 5. 47. f of f of 4. 48. g of g of 2. 49. g of g of 0. For the following exercises, use graphs of f of x, shown in Figure 6, g of x, shown in Figure 7, and h of x, shown in Figure 8, to evaluate the expressions. Figure 6. X. f of x. Figure 7. X. g of x. Figure 8. X. h of x. 50. g of f of 1. 51. g of f of 2. 52. f of g of 4. 53. f of g of 1. 54. f of h of 2. 55. h of f of 2. 56. f of g of h of 4. 57. f of g of f of negative 2. D. Numeric. For the following exercises, use the function values for f and g, shown in Table 3, to evaluate each expression. Table 3. X. f of x, g of x. For x equals 0, f of x is 7, and g of x is 9. For x equals 1, f of x is 6, and g of x is 5. For x equals 2, f of x is 5, and g of x is 6. For x equals 3, f of x is 8, and g of x is 2. For x equals 4, f of x is 4, and g of x is 1. For x equals 5, f of x is 0, and g of x is 8. For x equals 6, f of x is 2, and g of x is 7. For x equals 7, f of x is 1, and g of x is 3. For x equals 8, f of x is 9, and g of x is 4. For x equals 9, f of x is 3, and g of x is 0. 58. f of g of 8. 59. f of g of 5. 60. g of f of 5. 61. g of f of 3. 62. f of f of 4. 63. f of f of 1. 64. g of g of 2. 65. g of g of 6. For the following exercises, use the function values for f and g, shown in Table 4, to evaluate the expressions. Table 4. X. f of x, g of x. For x equals negative 3, f of x is 11, and g of x is negative 8. For x equals negative 2, f of x is 9, and g of x is negative 3. For x equals negative 1, f of x is 7, and g of x is 0. For x equals 0, f of x is 5, and g of x is 1. For x equals 1, f of x is 3, and g of x is 0. For x equals 2, f of x is 1, and g of x is negative 3. For x equals 3, f of x is negative 1, and g of x is negative 8. 66. F, composed with g at 1. 67. F, composed with g at 2. 68. G, composed with f at 2. 69. G, composed with f at 3. 70. G, composed with g at 1. 71. F, composed with f at 3. For the following exercises, use each pair of functions to find f of g of 0 and g of f of 0. 72. F of x equals 4x plus 8, g of x equals 7 minus x squared. 73. F of x equals 5x plus 7, g of x equals 4 minus 2x squared. 74. F of x equals square root of x plus 4, g of x equals 12 minus x cubed. 75. F of x equals 1 over x plus 2, g of x equals 4x plus 3. For the following exercises, use the functions f of x equals 2x squared plus 1 and g of x equals 3x plus 5 to evaluate or find the composite function as indicated. 76. F of g of 2. 77. F of g of x. 78. G of f of negative 3. 79. G, composed with g at x. E. Extensions. For the following exercises, use f of x equals x cubed plus 1 and g of x equals cube root of x minus 1. 80. Find f composed with g at x and g composed with f at x. Compare the two answers. 81. Find f composed with g at 2 and g composed with f at 2. 82. What is the domain of g composed with f at x? 83. What is the domain of f composed with g at x? 84. Let f of x equals 1 over x. A. Find f composed with f at x. B. Is f composed with f at x for any function f the same result as the answer to part A for any function? Explain. For the following exercises, let f of x equals open parenthesis x plus 1 closed parenthesis all to the 5th power. F of x equals x to the 5th power and g of x equals x plus 1. 85. True or false? G, composed with f at x equals f of x. 86. True or false? F, composed with g at x equals f of x. For the following exercises, find the composition when f of x equals x squared plus 2 for all x is greater than or equal to 0 and g of x equals square root of x minus 2. 87. F, composed with g at 6, g, composed with f at 6. 88. G, composed with f at a, f, composed with g at a. 89. F, composed with g at 11, g, composed with f at 11. F. Real-world applications. 90. The function d of p gives the number of items that will be demanded when the price is p. The production cost c of x is the cost of producing x items. To determine the cost of production when the price is $6, you would do which of the following? A. Evaluate it of c of 6. B. Evaluate c of d of 6. C. Solve d of c of x equals 6. D. Solve c of d of p equals 6. 91. The function a of d gives the pain level on a scale of 0 to 10 experienced by a patient with d milligrams of a pain-reducing drug in her system. The milligrams of the drug in the patient's system after t minutes is modeled by m of t. Which of the following would you do in order to determine when the patient will be at a pain level of 4? A. Evaluate A of m of 4. B. Evaluate m of A of 4. C. Solve A of m of t equals 4. D. Solve m of A of d equals 4. 92. A store offers customers a 30% discount on the price X of selected items. Then, the Santo retakes of F an additional 15% at the cash register. Write a price function P of X that computes the final price of the item in terms of the original price X. Hint. Use function composition to find your answer. 93. A raindrop hitting a lake makes a circular ripple. If the radius, in inches, grows as a function of time in minutes according to r of t equals 25 square root of t plus 2. Find the area of the ripple as a function of time. Find the area of the ripple at t equals 2. 94. A forest fire leaves behind an area of grass burned in an expanding circular pattern. If the radius of the circle of burning grass is increasing with time according to the formula r of t equals 2t plus 1. Express the area burned as a function of time, t of minutes. 95. Use the function you found in the previous exercise to find the total area burned after 5 minutes. 96. The radius r, in inches, of a spherical balloon is related to the volume, v, by r of v equals cube root of 3 volts over 4 pi. Air is V4N pumped into the balloon, so the volume after t seconds is given by V of t equals 10 plus 20t. A. Find the composite function r of v of t. B. Find the exact time when the radius reaches 10 inches. 97. The number of bacteria in a refrigerated food product is given by N of t equals 23t squared minus 56t. Plus 1, 3, is less than, t is less than, 33. Where T is the temperature of the food. When the food is removed from the refrigerator, the temperature is given by T of T equals 5T plus 1.5. Where T is the time in hours. A. Find the composite function N of T. B. Find the time, round to 2 decimal places, when the bacteria count reaches 6,752.